Okay, so the stream should be online. Let me just check. Okay, yeah, we should be streaming. Okay. Oh, let me turn off the do not disturb. Okay, guys, I think we're ready to get started. Let me just make sure that the chat is working, and then we'll be on our way. How do I do this? Let's do it like this. Channel. Yeah, that's live. Great. Hello. Hello. I don't know how to get comments on my phone right now. Okay, so how do I do this? Wait. Yeah, there we go. Cool. Okay, thank you for being patient. We're just going to watch Sigrid for 2 hours. That's all we're going to do today, guys. So let's talk about what we're going to get done. I started taking notes for the beginning of each screencast so that you have a concept of what we're going to cover for the first part and the second part. Now, for what it's worth, whether this is your first time watching or you've watched before, effectively, is going to be focused on finishing this search engine thing that we're building. For what it's worth, I've completely stripped any design from it because we're still working on it. It's actually much easier to forget about the CSS until the very, very end. Because as things change, the CSS might have to change. That being said, I might try to factor in the CSS that I wrote for this other project because I think it looks really nice, and I think that that would be a good interface for this. So we'll see if we have time for this. But the point is, don't be alarmed that this isn't sort of fancy, because the functionality really matters more first. All right, so this would be like the first section. In the second section is going to be focused on a completely separate project, which would be like creating like an animated emoji game thing that I still have to sort of figure out how to do, but that's sort of the point, right? That we're, if you see me sort of making this up on the spot, I hope that that gives you confidence that you can share your own idea for how you might solve a problem. I think that's a much more creative way to go about this. Hey, Emin, thank you again for joining us, and thank you, Anna. You guys are the best. I assume Nick's here, and if he's not, it's no problem. All right, so there's one thing that... Oh, and I think Prakash is supposed to be here, too. If you're here, Prakash, go ahead and say something. All right, so the first thing I want to do is actually this. First, I want to show you the build process that I designed for the Twitter bots, because I think it's really cool, and it's sort of like a mind changer when you see something like this. So let me show you, right? If we go to Chrome and I go to 100 days of code, the bot, right? The bot here. So this is 100 days of code with an underscore. I want to show you the commands that I press to just like launch this thing, because it's almost like pressing like a big red button. It's almost that simple. For what it's worth, this thing has only existed for like a week and a half, maybe 2 weeks, and it's already racked up 300 followers. So bots can be effective. The only difference with this bot, you have to be careful because like sometimes it'll retweet just like completely bogus stuff. Yeah, I have to be careful. The point is it's supposed to filter the bullshit tweets from like the real tweets. So sometimes, like 1% of the time, something slips through. Okay, so let me show you how the build process works for this, because it's actually not just 100 days of code. When I run this build process, what actually happens is 100 days of code, moms can code with an underscore, and women who code are all deployed at the same time. And I think that's really cool. So let me show you how I do this. Obviously, you can do this your own way. Okay, so on my computer, I have a directory called TwitterBot, right? And because it's a Go file, it's a Go project, I have a couple of folders. This one is not relevant, but these would be the 3 that you're expected to use whenever you make a Go project. So I'm going to go into my src for source, and inside of here, I have a whole bunch of files, right? Now, the ones that I care about, they're sort of scattered in between, and if I put them in a separate folder, sometimes it complains. So what I've done is I've written a build process, right? So sometimes people will use like a make command. I think it's make, right? Because like make is yeah, make is like another way to do this, but you can also use shell scripts. So anytime I type something into here, like echo hello, whoops, I need to be careful with this exclamation mark, because that's actually a command itself, right? So I can do like, here, I can do like that, right? So if I do echo hello, if I want to save this for later, I can do like vim command.sh. sh is for shell, I believe. So I save that, and now if I run, I can run it by using the dot, just like that. I can do dot command.sh, and then that will run the command. So what I've effectively done is put all of the commands next to each other in one shell command. And then on my server, I'm just going to log in. My server, it receives the files and then executes it. So let's do this in like 3 steps. First, I'm going to prepare the server. Second, I'm going to send over the executables. And then third, I'm going to run the executables. So we're basically going to clean some stuff up, ship some stuff, and then we're going to run some stuff. So I'm in the server, right? And how I can do this, so I've got all these files. Let me check the errors. Okay, these are not a big deal. So I got some errors that says, hey, you've already favorited this, you've already retweeted this, it's not a big deal. So I'm going to just delete basically everything on the server except for the build process. So if I have 2, I have kill and I have kill, run, and clean. So first I want to kill the bots. Actually, we can kill them, we can wait to the very last second to kill them. So in the meantime, we're going to do clean. So I'm just going to call my clean command. Let me show you what it does. So clean is literally just going to remove any file that matches this pattern. So this is my 100 days of code, women who code, and moms can code files. The asterisk is just like any of the above. And I have this little backslash. This means I can drop down to a new line, and it doesn't interpret that as a new command. It's the same command, just spread over. Hey, Nick, thanks for joining us. All right, so what I can do is I can call .clean.sh, and then now I've effectively deleted the files. Now I just have my build process. But oddly enough, that does not stop the bots from running. So here, I can see the bots are still running just fine. At least I think they are, right? So now I go back to my local computer. I have a command called ship right here. I can go vim ship, and then inside of it, this basically means I'm telling the computer, it's a command I wrote, I'm telling the computer to go ahead and prepare the computer to compile a program and send it to a Linux or Unix-based computer. So I'm not compiling it for my own computer. I'm going to compile it for another computer and send it. Then I have 3 build commands. And then last, this will send it to the server. So SCP is like SSH. I'm sending it to the server. Then I'm going to delete the files that I created that I don't need anymore, and then turn off cross-compilation. So now I can do .ship.sh, and you're going to see this, right? It's literally building everything, and it's shipping it to the server right now. So it's built the 3 bots, and done. Now I go back to the server. I just need to kill the existing bots, and then last, all I need to do is .run. And that's it, right? So now I have all these files, and I can check all the standard error and the standard output at the same time. So I have 2 asterisks, right? I have the first asterisk to match against 1DC, MCC, and WWC to check those, right, those 3 bots. And then std star checks my standard output and my standard error at the same time. And if I have no output, that's perfect, because it means the bots are running and they're not reporting anything particularly, right? So that's ideal. At the same time, I can check and I can see that they are running just fine right here, right? So if we wait just like a second, I'm sure 100 Days of Code will retweet something because it happens often enough. So this was 1 minute ago. I wonder if that was before or after we shut down the server. But the point is, like, right, like this is really cool. We only had the server offline for like a few seconds. So this is pretty powerful, and I'm like really getting used to this sort of like design, right? You don't have this like intense complexity. You have a few commands. You understand what they do. You name them correctly. And we've just redeployed 100 Days of Code, Moms Can Code, and Women Who Code, right? So we just like turn them off, turn them on, and that was the extent of the complexity. So I think that's really cool. Okay, so I just wanted to explain that. So we got this off of our list. And here, if Prakash is in the chat, he wanted to ask some questions about CSS just before we get started. Or if anyone else has any like general questions before we get started, now would probably be the best time. So go ahead and ask if you have any. Don't forget to thumbs up and subscribe. Seriously. Guess Prakash isn't here. Sorry, I'm trying to open some dumplings. It's like childproof. Okay. All right, so if you guys have questions, you can always ask them later or right now, but I think we'll just keep going because I think we don't have any questions yet. Okay, so we talked about the build process. If we have questions, we'll come back to them later, so no problem there. Okay, so we are going to finish up the thing that we've been building. Now, before we continue, I want to show you guys something really cool. So Per, who is like CEO of Scrimba, just released a micro course, micro meaning like small, teaching Vue in terms of the documentation. So this is actually pretty exciting. If you go to Vue on the website and you check the docs, there are now Scrimba lessons embedded inside the official documentation. This is pretty exciting. And this is a nice balance because my course is going to be it's going to be structured, but it's also going to be much more creative. And this is more just sort of like programmatic, which is fine because you really need the balance. But I want to focus, let me put this in the chat. I want to show you one example because I haven't used templates whatsoever, just because I haven't understood how they work, and I today understand how they work, and I want to show you because templates can reduce the complexity when building Vue tremendously, right? So here's the link right there. So let's do a quick example because I want to use this in the things that we're building, and I don't know where they fit in yet, but I want to show you so we have sort of a shared knowledge of how it works. Okay. So in this example, let me just show you how he's doing this. So effectively, there's nothing here that should be overwhelmingly complex. If I remove this and put this here, right? So like so far, we're comfortable with IDing a div, give it the value of app. That's how we plug in our Vue to our website. I've just got an ordered list, could be an unordered list, doesn't matter, and then I've got some list items. So the point is, if you have a lot of code that you are repeating and vanilla HTML is not enough for you, you sort of need to like have all these things happening and you want to reduce the complexity. Here's an example, right? So in this thing, what he's doing is he's saying, if I have this like complex thing that I want to repeat, oops, let me do this. If I have this complex thing that I want to repeat, what I can do is I can do like to-do item, right? So I can make an HTML component. And the cool thing is that this is almost like a macro. This can, by putting that there, Vue will basically go into the website and like replace it with something else. And I want to show you the significance of this. So like let's say every time I have a to-do item, right? Like every time I want Vue to go and replace it with this instead. So that's called a template, right? We're using a template to template some piece of our HTML. Now I need to formally tell Vue what I want the name of this thing to be, which is the component. So the template is the actual code that it's swapping it with. And the whole thing, the thing that Vue understands it as, is a component. So here's the component, and here is the template. Now you'll notice that designing components are very similar to instantiating an app with Vue, right? So all I need to do is call upon Vue, and I say, hey, I'm going to register going to register a new component, and the name of the component is whatever I want it to be. So this could be like Google Maps, this could be anything. But in the example that Pear has, he just has to-do item, right? Now if I look at the template, what's going to happen is that this code will be swapped out for here. Now this isn't really that exciting because in this example it's so obscure that the benefits aren't obvious. But you can do something pretty interesting, right? So whenever you hear about React, you're going to hear the word props. Props, right? You're going to hear this all the time. It's sort of like a headache, like props this, props that, right? And it's like if you don't know what props are, it's like already like annoying, right? So props. Oh, are you lagging? Let me check my phone because that's also got the live stream. It's looking okay for me, Anna. Let me check my Wi-Fi. And let me check my speed. Yeah, it might just be like a quick thing, Anna. But I've got a strong connection, so it should be alright. Anyway, it should save the video just in case it gets worse. It should save the video in like smoothly. It shouldn't save the lagged version. So it shouldn't. I'm sorry, that's happening though. So props is for properties. And it's like, okay, what's a property? Well, properties is another way of saying a variable. Let me do like this. Variable attached to a thing. Well, what's a thing, right? And a thing in like traditional programming languages, in traditional programming languages would be like struct. But if we're in JavaScript, this would be like an object, right? So if I have an object and I'm going to attach a variable to it, I can't use this syntax, right? But I can use this syntax, right? So now I have an object that has a property, right? So when people talk about props, that's what they're talking about. Now, if I want to give my component its own sort of property, I can do that. So remember on the left side over here, we're not coming up with the name, right? So here, like we're used to like elements, or we're used to methods with an S, right? Oops, methods. We can also use template, and so template goes here, and so we're defining the string that we effectively want to mix in to our website. Now, if I wanted to do more than just mix in, and I wanted to sort of take an argument, like very similar to a function, right? What I can do is this. I can go props. So props. I need to put a comma at the end, and then I can define an array of the properties. So let's say I put like a message, right? So I have a message, and I want to interpolate my message right here. So I can use the Vue syntax. Now this is really cool because all I need to do is I save that, I go to my index, and then right here, I pass my message as an attribute. So I literally go like this, right? Hello world. Now in theory, unless I like botch this, we still get hello world. Now this is still sort of obscure. Like this, I don't understand the benefit, but like if you have a lot of code in here, then you can swap the whole thing out for a template and then just pass an argument. Now the thing is, this is still a bit dull. Where it gets really exciting is you can have multiple properties, which is sort of cool, but you can also pass native data types. So I can pass message, and message right now is a string, but message could also be an object. It could be a function, right? This is interesting. So like, let's try a quick example. Let's say properties takes a function and a method, right? Then I want to call my function on my method. Ooh, right? So all that's missing, let's go to our index, and we're going to pass a function. We need to define the function that we're going to pass somewhere in our component. So we'll do that here. We'll do like, whoops, we'll do like this. So now we're going to define a function that we're going to pass to it. But that's like sort of annoying. Like, what if I want the function to also belong to here, right? So like if you want to share a function between components in your app, which is like what I would expect, how I would expect to use Vue, what I can do is instead is do this, right? So like, let's say I want to pass a function that's called capitalize. Let's do like caps, right? Now, instead of defining the function and the logic right here, because that's like sort of repetitive if I need to do the same thing down here, it'd be much nicer if I have like a global capitalization function. So like, let's do the scientific method real quick. We're going to make a function that capitalizes. So I go to console and I'll say like function caps, and it takes a string, and then I just say like return s to uppercase maybe. Then I say caps hello world lowercase. Okay, so now we have a capitalization function. That was the scientific method brought to you by Anna Rodriguez. So here's caps, and then we'll say caps capitalizes, duh, right? So caps capitalizes. Now I want this function to be accessible from inside of my app and my component. Well, that's actually, I can recycle it. So now I'm effectively recycling the global capitalization function and creating a local copy of it here. Now I can take this bit of code, drop down to here, drop down to here. So I have element, comma, methods, and then I'm just defining caps as caps. So now my component and my app are sharing the same method, right? And this is a functional method because it's not mutating the input. So it would be, so this is a functional function. It would be imperative if it permanently updates s instead of just returning a new copy of s. Okay, so now if we wanted to pass, like let's say for example I had a capitalization function and I had a lowercase function. It'd be nice if I could choose either function to pass as an argument, because then I can do really cool sort of stuff. So all I need to do is, this is this, so this looks good. This is good. So if I run this and I just leave function empty, I want to see if that compiles. Scientific method. They're saying fn is not a function. Okay, let's just double check. Okay, so it said fn is not a function. So we've only defined fn here and fn here. And it's not a function because we haven't passed it. So what I should be able to do is this. I believe I can get rid of this because we're going to use this capitalization and we're going to pass it as to an argument. So in theory, this doesn't need knowledge of the function like I did a second ago. I believe we can just do this instead. So let's see if I can figure this out. We need to pass it as a function. There's a function. Now I can put caps. Now I'm not going to expect this to work on the first run because if I do it like this, it's going to receive a string. And it's going to be like, yo, that's not a function. I can't like string a string, right? So what I can do instead is I need to use vbind, which will give me access to the argument as like a native JavaScript thing and not just a string. Now the shortcut for this is like that. So let's see if this works. That's a big deal. Because it means we like have a method, not a method, but we have like a method to create a component that can take an argument, whether it's a native JavaScript thing or just a string, and like do whatever it wants with it. And because we've defined a global caps function, we can not repeat ourselves, right? So this is called the dry method. Do not repeat yourself. We're recycling this one function that is functional, and we've just done that here. And because of that, now we can just refer to it in our website. So the thing is, like, I've understood most of Vue, but without components, Vue is kind of cool. It's like fine. If you combine a working knowledge of Vue with components, that's really powerful. Because like in the documentation, they're like, what if your like website was like app bar, like this is like, I think it's like the actual example. They're saying once you understand this sort of design, you can like write entire websites like this, right? And that could be the entire extent of your app, right? Given that you have powerful enough components, then you need to pass them arguments. Well, we know how to do that. And we know how to do that with either string or like an actual JavaScript type. So this is a pretty significant thing that I did not know how to do until a couple hours ago. Just in time, basically. Okay, so that knocked off, that knocked up this one, this one, this one, this one. Okay, so that's good. Okay, so what I'd like to do now is use Go to create our own API, a very simple, cute and simple API. We'll need to figure out how to, so we're going to produce information. We'll need our website, our client, to consume the information. So the server will produce an API. Our client, the computer that we're working on, will consume the API and throw the data up on the screen. That combination means that if we understand how APIs work, we understand how to consume them and paint them to our website, this could become an actual useful thing using a real API. Now, the reason I'm not going to use an actual API is because each API is different. There's not a standard. You document your API, you write it whatever way that works for your business, which is fine, except that most APIs are not interoperable. I can't just be turn this API on. I don't like that data. Turn this API on instead. I'd have to work with the differences defined in each API, which is sort of a pain. So to not deal with that, we're going to make a minimalistic API that does not care about IMDb. It doesn't care about Rotten Tomatoes. It's just a simple API. But that is still that's still enough information for us to sort of turn this into an actual thing. Then after all of that, we can try to very quickly make this thing pretty. I thought about using Bulma for this, but I sort of think doing things as close to scratch as you can without sort of taking too much time is usually the best pattern. So I'd like to try beautifying it ourselves rather than using a CSS framework just because there's more education sort of to behold, in my opinion. You guys want to do any questions at all before we sort of keep going? / I just want to eat something without feeling bad about it. It's about a 10-second delay for me to get questions for what it's worth. Oops. Yeah. So simple CSS, which this, the thing I want to do is this, and this is simple CSS. The nice thing is with the debugger turned on, there's really no surprises. So yeah, you can, I think people sort of get ahead of themselves with CSS, and they're like, I want to make the coolest, most beautiful UI, UX. If it doesn't work, it doesn't matter. And you can do, the only thing that changes is the width of the button, the text weight, whether it's capitalized or not, and colors. And still, this sort of seems like a pretty functional thing, and it's responsive. So you don't need to be a mastermind to make something that's beautiful. This is what our website looks like because I've taken all the CSS out so we can focus on the functionality. Okay. I think we're good to keep going. So, we'll recap how our app works and how it looks. I'll show you the code. I refactored a few things to make it nicer. But this is how it pretty much works right now. So at the top, that is intense. We basically have these 3 buttons. We have year, title, and rating. And what's actually happening on the right side is we have these 3 inputs, but they're only showing one at a time, which means that the controls for each of these can be completely separate. Whether this was text and then this one was number based, or it used some other method of grabbing data from the user, it doesn't matter because we're just hiding and showing them. And if they occupy the same space, it's really nice because there's no the UI doesn't change. It doesn't get bigger or smaller every time we press a button. So even though this has no CSS, this is analogous to how it would feel, right? We just we're clicking a button, we're turning it on, we're turning it off. Okay, so now what I can do is this is how it works, right? So I have ratings on the left, I have the title, and then I have the year. And this actually stores 3 different things in memory. It's not one giant string. It's basically an object that has 3 fields inside of it. Let me open that file for you. So let's go to, where is this in Vue? Yeah, here. Okay, so Sublime data. So this is what the data looks like right now, and we're going to put this inside of Go. So basically, our data has a year, which is stored as a literal number. We have a title, which is stored as a string, so there's no surprises there. And the rating, again, is a number, it just has a decimal. But because JavaScript only has one native number type, these are actually the same type, which has some sort of benefits and it has some cons, but for now it's fine. And we have 250 data as input, and because we're sort of starting to understand how to build this, we only have 3 dimensions of information. If we had 18, it would not matter, because we're just writing a filtering function that checks, is this true or is this false, right? So you can have an arbitrarily complex amount of data as your actual the thing, because this doesn't have to be for movies or TV shows. This could be for anything. And you can have as many dimensions of information as you want, as long as you have a filtering function that can deal with each type of data. Okay, so let's say, I'll take recommendations, but let's say I want to search for a movie. It has no particular title. So this is a placeholder. It's not actually, sort of confusing. It's just a placeholder. There's nothing there. Let's say, give me any movie, so any title that has a rating of 7.5. We'll do 7.6. And I want it to be from 2009 or after. You see that? Right, so something's changing as we do that. So now, if we look at the data, we've got 50 or 100 results. But I can just as easily say, no, I want 2015 and after. I want 2018 and after, right? And so this is cool. This is an instant API that allows us to take a giant movie list and find something of meaning. Now imagine we have another filter, we have an option for the genre, we have an option for the director, we have an option for the actor, we have an option for the box office performance. This would be really nice because I'm not showing you these 3 bars at the same time. I'm only showing you one at a time. So we could add an arbitrarily complex amount of buttons and just hide or show them depending on which one we're selected on. So that's pretty cool. How's the sound? Is the sound still okay? Any questions? Okay, so let's define an API very, very quickly in Go. So I have this little piece of code. It's going to be how I start things off. So I'm going to go inside of the folder, and I'm going to make a thing called api.go. Okay, so here we are. Now, all Go files have, at the top they have, sorry about the noise, I have package main at the top, then I have func main, and this is the minimum required code to get started. Now, there's something called Go imports, which will make your code, it'll format your code for you. So in case you have this mess and you want to clean it up, you can just hit Go imports like that. Just amazing. And Go imports works for dependencies too. So if I have thumped println, which is a printf, and I want to include that dependency automatically, that is done for me. So there's less typing that's needed when you're writing in Go. Okay, so we're going to make our own API, and I believe this is the function that we need to use to get started. So basically we're calling the, wait a minute, this is a function that takes, so my friend Johan is helping me out with this. Let's see. So if I don't get Go imports, that's a clue that there's something wrong. Okay, so like let's see what the error is. Oh, this should be, no, that's a little, let's do it like this. Let's do func API. Func API needs to follow this signature. Would like that, and then like this. So we're defining a func for a function, and it's called API, and it takes 2 parameters. You don't have to worry about what this means, but the point is it takes 2 inputs. It doesn't appear to return anything, so nothing goes here. And then inside of the function, we do something. Then this should be fine to call API like that. Okay. There we go. Okay, so basically, our program, whenever somebody hits our website and they go to like website.com/API, if somebody visits this URL, like website obviously is just a placeholder, but if somebody visits this website, our backend basically has a method for dealing with queries that are hitting /API. So like mymovies.com/API, that would be how we connect this to our API. And then it needs to basically, it's taking a function as an argument. So we're basically taking all of the logic here and using that as an argument for HTTP handle. So let me just open the docs. So let's do Golang HTTP. Sounds cool. HTTP. And then I go to handle. Okay. So this is handle. So handle registers the handler and does some stuff. Okay, let's see if we can get this to work. I should have asked, how do I do this? So, I do know how to do this. I just need to, yeah, Johan, help me out. I just need to write something effectively. So like, let's see if we can do this. I'm gonna go to Sublime. Here we go. Okay. So we're gonna write some data to here. So like if I hit API right now, it would return this stuff. Let's do like this. Let's do like let's do like let's do like this. Did this work? Oh, let's do like this. Did this work? And then we'll do true. So we're basically sending stringified JSON as a response for somebody hitting our server. I have to figure out how request works because I don't remember. So you have handle func. So API is for, okay, so HTTP handle, and then func handle. So what's the handler is an interface that calls serve HTTP. Okay, so that's like that. Okay, let's just try this. I don't know if this is going to work. We just want to see if this even compiles. That would be useful information. So we're inside of movies. I have the file called api.go. Now because this is Go, I actually need to be a little pedantic. I need to put this in like a Go environment. So I'm going to do that real quick. I'm going to make a workspace and move my source code into src. Whoops, src. Okay, so now here's the tree. I've got some files, but the thing that I care about the most is that I've got my program inside of api.go. So let's go to source and let's just try spinning this up. So go run API. Uh-oh, so 610, it's saying, oh, let's do this. Let's open this again. Sublime API? Yeah. And then go run API. Invalid character, literal, more than one character, line 6. Oh, maybe that's because it's a character, not a string. Cannot use as string as type. Okay, so this, basically it's complaining about the type. This needs to be converted into a byte array. Okay, I think we're making progress. Let's do like that. Into a type byte. Hang on, I just need to look up the docs. Go doc. HTTP. What is this? A writer? It's a writer. Where's writer defined? Writer would be defined in here? Here. So it takes an array of bytes. Oh, maybe I can do like this. Oops. Okay, it stopped complaining about that. So basically, I have a string, I'm converting it to this special data type, and I'm writing it, instead of like to standard output or to standard error, I'm writing it to my response. The response being like, right, the server takes requests and it sends responses. So we're writing to the response right now. And it's saying, cannot use this function in argument, does not implement. Right, okay, so this is not exactly what we need to do. I wonder if I can just do that. I think I've done this before. Let me just check my computer. I think here I've done this before. Let's try web and cd web server. Okay, let's check how we do this. Cd tree, cd, there's no go file there. Let's try here. Cd source, that looks better. Sublime main.go. So this listens on 880, and this is a file server. It's not exactly what I want. Okay, we need to look this up real quick. Response writer, okay, so let's go back, leave that, run that, as type HTTP handler, okay, Golang simple API. Okay, let's find out how to do this. Oh yeah, Emin, do you know how? You don't have to write it, but I'm just forgetting which function we need to use as the handler. I just need to figure that out real quick. This looks right. So we have a response writer. We have a request. Yeah, that's right. Oh, cool. If you could do it in Go, I'd prefer that. If not, I can just figure it out real quick. I just need to find like a code snippet for it. But I know it's simple. I'm just forgetting how to do it. This looks right. That looks right. This should be fine. Oh, yeah, we need to start the server too. I forgot about that. Okay, let's start here. So let's comment this out. Let's come back to it later if we feel more confident. And let's just bootstrap a server using somebody else's code. Okay, so now we have the server and it's running. And in theory, if we access it, it'll give us a string. Okay, so now I need to figure out what my IP address is. There's different ways to do this. What's my IP address? Okay, so like in theory, I could be doing this, wait, I could be doing this wrong. Let me check. I think I need to access my IP, and then I need to put the port 880, right, at the end, and let's see what happens. Nothing. So sad. Hang on. Does this look right, Emin? Wait, that worked. Okay. I think this is working. Unless it's like doing something else. Yeah, so do I not need to put 880? Or I'm just like listening and serving it? So let's try like API now. So let's do like that. And then now this one shouldn't work any. Wait, I need to rebuild it. Hang on. Okay, so we save this. We go back to here. We refresh. Okay, so if somebody accesses our website, it's supposed to print. Here, let's just do like print line connected. Okay, let's try this again. So if I refresh this, do I get a signal? I'm doing something wrong. I thought I needed to do like that. API? Still not it. Basically, if it works, we should get like feedback. It should say that we're connected. So if I go to /API, I'm going to call this function right here in the code. I don't think that matters. If something bad happens, error, and that's fine. So like, yeah, so like my local IP address is being assigned to me. What's my IP? Oh, local. Sorry, I'm being an idiot. You mean like the 127 thing? That one? Is that what you mean? So that would be 127.0.0.1. Is that right, Emin? I hope so. Let's try that. So it should only work if we access /API. So no. What about like with the port? Okay, that's, yeah. Okay, I think that's it. Okay, cool. So now we've created a terrible, terrible API. Thank you, Emin. So basically, let me just, now that it's working, I can show you what it's doing. Yeah, so it says connected. And that means that this was not commented out. Okay, so basically, this is the simplest API you could possibly write. You're basically defining how the API works here. So we're defining, hey, if somebody accesses this website, then we're going to call this function. Now this is sort of obscure. It's actually a little bit easier if you put it in a separate area and then you just reference the name of the function. So I have a pretty fair confidence that I can do that. Like, let's just go here, make that API, go here, and then define this as API. So now we're basically delegating. We're saying, hey, if somebody accesses this website, delegate to this function. And this function has its own internal method for dealing with requests and responses. So, like here, in theory, it's like capturing the request, basically printing like a hello world, and then this is just for us to make sure that it worked. But I don't need this anymore. So now, let me restart the server. It works. I go to the, oh yeah, so this is great. So this is effectively a hello world, and it's saying hello, and then in quotations, the name of the URL that we are accessing, right? So it's saying hello world, but it's hello API. If I refresh it, the only thing that changes, it's now running this code, and we don't see connected anymore. So that was just a debugging message, right? So there's nothing here. Okay, so now we have our own API, and this is fine. We want to use API. This is fine. Basically, if there's an error, the whole thing will crash. So we define how the API works here, and then if anything goes wrong, it's going to log it. So this is basically defining the behavior for this server, and this is dealing with, it's like this is the actual serving part of the server. This is where we serve the server and crash on an error. So that's what these two lines of code are doing. And our dependencies are here. Funct for format, HTML for HTML, log for logging, and then this is a dependency inside of the net standard library package. So we have basically, like, it's like a module inside of a module, right? So we're just grabbing HTTP. I don't think we're grabbing net unless, well, just ignore that. Okay, so here, what we need to do is basically serve our API as a string. So we're doing everything through the browser. In reality, we want to do this through the command line. So let's go to this website here, go into terminal, and okay, so we're running the server, and we're going to use curl. Curl is a way that we can basically grab stuff from URLs. We're going to curl our own website that we just made. So this is pretty cool, right? So here's our website, and we're just going to curl it. Oh, that worked. You see that? That was really easy. So let's do like this. Let's do like, hi Anna, oops, Anna, Nick, Emin, love you all. And then I can use print line, not print f. And that doesn't need an argument. Okay, so now if I query the server, oh, I need to, sorry, this always happens. Whenever you're like dealing with the server, you have to start it up again. Now I have an unused dependency, so I can use go imports to deal with that. It's gone. And now I just run it, go to curl, and hit that URL. And so now we have a server. It's not serving a functional, like it's not serving an object that we can make sense of, but it is serving something. So if we were really lazy, we could call it a day because we could effectively just do this. We could be like, yo, I'm about to just put in all my data and I don't care about how it looks for you. So like right now, I think we could just do this. This is like so lazy. It's kind of cheating. Not really, but it is. So basically, we go like that. And now our server should give us this giant string, which is a little excessive. I need to restart it. And we could like basically call it a day as far as like the server stuff goes. Because now we have a server, we know how to access it, whether it's on a website or we're accessing it through the command line. And it's giving us some stringified data. Now the thing is, when this hits our website, it's still not ready to be painted to the DOM. We still need to make sense of this. So we effectively need to use some standard library or feature of JavaScript to take this data and what's called, I think it's called unmarshalling it, or like deserialization. We basically need to turn this into a native data type. So we need to figure out how to do that. Do you guys want me to show you how to like do this whole thing in actual Go, or is this fine for now? What do you think? It would take like another 10 minutes maybe. Okay, so I can show you. Great. Okay, so JavaScript likes objects. Most traditional programming languages, on the other side, like structs. So just like it's a difference. So effectively, if we think about what this data type really is, actually let me get rid of the data because it's a bit too big. So we have the data, and this would be like data, var data, and then we'll put like hello world. So right now we're only going to send hello world, where in the future we're going to send this, but coming from Go natively, not as like a cheating string. So let's think about this. If you think about this as a struct, which is just a group of variables packaged together, we have three things, right? We have the year, we have a title, and we have the rating. So let's just take one of these. And what we can do is define a struct, and we have to do like type, like what are we going to call this struct? We'll call it like title. So each of these items we can refer to individually as a title, and each of these titles has three values, right? So it has a year, which would be an int. We have a title, which would be a string, and we have a rating, which would be a float 64, which is the primitive for like doubles or floating point. Okay, so like let's do this. Let me go into another Go program so we can do the scientific method, and we'll just make sure this is working. So we have struct.go, and let me comment this out. Let's do package main. We've defined a type. We're calling each of these things a title. And then in my func main, I'm going to turn on imports, and that formats everything for us. So this is pretty cool. If I wanted to define individually one title, I could do like title is equal to, oh, I have a problem now. Let me make this uppercase. And I could say my title has three values. And I basically just do like this, right? So this is pretty much like an object in this sense. Let's do like that, and let's do like that. Okay, so you can see how we've converted these types from JavaScript to Golang. Now let's capitalize this. Oops, that was bad. Okay, and then let's do funct println title. So now let's import. Okay, cool. So now if I run this, I should basically just get this with these values printed out. So let's try that. So let's go to iterm, cd movies, cd source. Okay, go run, what is this called? Struct. And saying, hey, I don't like that because on line 13 I don't have a comma. Or no, now I need to do imports. Okay. So this is how Go would show you the data natively. So there's two things we can do here. I can get the extended data type, I can get the extended format, which is like this, where the basic one is like this. So this is basic printing, and this is sort of like advanced printing. If I put a plus here, and I put a new line, because we're not using print line anymore, we're using print, and specifically printf. So now I get some more information, but it's still sort of not ideal. So what I can do is define a custom printing method for a title. So I can say t is short for title. So anytime I'm inside of this function, instead of like in JavaScript, instead of saying this, I would just say t. And then it's going to, we're going to call the string method, and it's going to return a string. That's the definition to give it a custom printing method over here. So I can just do print line now. And all I want to do is format this in a way that feels good. So I can do like return. Now instead of printf, which we're used to, we're going to use sprintf, which allows us to basically create a string using the printf scheme, but it doesn't print it, it just returns it. So we're going to return the string, and whenever we do print line on this type, it's going to look for this function, which will return a string, and then in return print it. So that's sort of what's happening here. So we're going to print the title's year, the title's title, and the title's rating. And the only thing that's left is to format it. So like let's say, actually, I want to put the rating first, and I want it to be always 2 digits, so I can use the float format, and always have 2 zeros no matter what, so like 0.0, right? That's the style. Then I have my title, and then in parentheses I can put the year. And that's pretty much how it looks when we go to our app, right? We have that sort of design. So I'm sort of fond of this. This is here. So that's all we need to do to give this a custom printing method. And now I should be able to go back here, print it, and I get this nice format. Oh. This is a int, so I need to use D for decimal. So I get 7.2. It's actually too many zeros. Let's do 1F. Okay, so now you can start to imagine we understand how an API works. We understand how to sort of print an individual title. So this is sort of like the stringification. What we need to do is 2 more steps. We need to do this for tons of titles, so we need to work with an array, not specifically one. And this still is not ready for a JSON object, so we still have to do one more thing. So the first thing we can do is do this for an array. There's 2 ways we could do this. We could say, instead, I'm going to use an array of titles, and then I would need to define an array of titles like that, or I think it's a little bit nicer if instead I do like this. I can do type title is actually pointing to an array of titles, right? So that, titles. That is all we need to do to define another type that we can use to point to an array of this so that this doesn't get all messed up, right? So now I can do give me an array of titles, and then I put each one of these in this special syntax. Now in theory, I think this is how I do it. I just need to have a second title. So let's jump over to our web app and let's get the Black Panther and let's put that in data as if it was raw or like a native data type. So we do year, title, and rating. So we do 7.5 was the rating. Black Panther is the title. Did you guys see this? I haven't seen Black Panther. Should I? Let me know in the comments. And then the year is also an int. And so because this has a decimal, Go will figure out that this is intending to be a float and not something else. Okay, so let's see if this works. I'm not actually sure that that will work, but I believe, let's do titles and like that. So the thing is, we don't have a printing for, we don't know how to print this yet, so this is going to give us some raw data, but we can add another one of these in just a sec. So let's try this. Okay, that worked, right? So it's printing the array syntax. Okay, so now all we need to do is define another string method, but this time instead of for title, it's for titles. So TS is just sort of an acronym for that. And now we need to do something a little bit more fancy. So what I can do is, can I make this shorter? It's a bit long. Yeah, it sort of looks weird. Oh. It just, okay, that's does Go, okay, Go likes that, doesn't matter. Actually, you know what we could do? This is why I'm getting confused. We could also do it like this. Oops. We could make this look like an object on one line. So you can see how like the combination of Go and JavaScript and Vue is really powerful because Go is very, very good for writing complex concurrent programs and stuff, and JavaScript with Vue makes creating a front end like pretty painless compared to what you would have to do. So we're getting very close. The actual sort of way that we're supposed to do this is to use a marshaller. So I might need to look that up. I'll show you sort of the ridiculous way to do this, and then we're going to try to do this like the correct way. So I could do like a for loop, and I'm going to iterate over each title in the titles, and then I need like an output string, so I do like var out str ing, right? And then we're going to return that string when we're done. So I'm going to do return out. So we're basically going to use this function to compose a string that we're going to return. Then I'm just going to do out plus equals print sprint. And we're going to grab this one, right? So all we need to do is put t. And so now it's going to be appending it. And that will create like a giant string, and when we're done, we can just send that on our way. The thing is, assuming that we wanted this format, it's going to print it right next to each other, so we probably want to do something like this. We probably want like there to be like a new line before and after it, maybe like a comma. And then like at the beginning of it, maybe we put like a open parentheses, and then we like defer. That's a little weird. Let's do like right before we return it, we'll do out plus equals. We'll do like we're going to close it off. So this is sort of a ridiculous way to prepare some data, but I think it's a good point because it sort of gives you sort of an idea of how to think about this. Let's see if that works. It didn't like ranging over. Oh, because I need range. It still didn't work. Did I do something wrong? So TS is for titles, print titles. Let's just do test. So we want to check that it entered this function. It never entered that function. So there's something wrong with this signature. Oh, because I'm not using the actual titles. Okay, so I was using the wrong data type. So let's try that. Okay, so this is sort of working. And then like let's do a tab. Okay, and then when we're done, we want like a new line. Okay. So like that works, and then like we'd still have to make this look like JSON. But the point is to give you sort of an idea of how this stuff is sort of happening behind the scenes. Now, we need to do this correctly, so instead of using the string method, we're going to use the marshaller stuff. So we can go to Golang marshal. And Go has a pretty cool technique for doing this. So we're going to encode it as JSON, which means we need to give a special this thing. So if you've probably never seen this before. These are called Struct Tags, and Struct Tags allow structs to have slightly more information, which is significant because it makes the JSONification of a struct very intuitive. So without having to actually write any logic, I should be able to define some tags right here. So I'm going to leave them as empty for now, and I want to show you that by doing this, nothing has functionally changed. So let's just hide this for later or never. So this should compile, and the point is that this is a legal thing that we can do in Go. Let's check. So yeah, the fact that Go didn't complain was the point. Now the actual syntax for this is quite simple. This is sort of how we're supposed to do it. So let me type it, and then I'll show you why this is really cool. So we do like that, and we do like that, and we do like this. And so like the thing is, this could be like XML. This could be JSON. This is a data interchangeable method for like marshalling your data from a raw data type into a string that can be consumed by a client. Okay, so here's the point. If I showed you the data, this is a JavaScript object, right? And our JavaScript object has a year, has a title, and a rating. So all I need to do to tell Go that this is the key and this is the value, and that the key should be year, the key should be title, and the key should be rating, is to basically give it a hint, right? So all I need to do is say, when you become JSON, I want you to use the string. And this is cool because we have loosely coupled the actual data type from the exported data type. So instead of making this year, if for whatever reason our server wanted to have like, this is the year lol, like that, then all I would need to do is just change this here, and I don't have to change this as well. So that's significant because if you need to update, change, or whatever your API, you can do that without having to rewrite major parts of your code. So it looks sort of useless right now, and that's because we're using the same name. And in fact, I actually might not need to do that. but it is how we're supposed to use the marshaller function. Okay, so you're familiar with how we use a custom string method to turn a data type into a printed string. We're going to do something similar, but instead of the string method, instead of the string method, we're going to use something called marshal, I believe. Still water. Emin, how are you keeping up? Just want to make sure. Sorry. Okay, so we want to define, is it a marshaller or an encoder? What does encode do? Writes JSON values to an output stream. I don't think we want that. I think we just want to marshal it. Okay, so we're going to copy this function signature, and I think that's all we need to do. Oh, great. I haven't done this for a while, so I sort of have to like figure this out. So we're going to define a method for titles. So we do func ts titles, and it needs to have this exact signature for Go to recognize it. The point is, when we're done, we need to give back an array of bytes, which is effectively a string, but Go likes to use this instead. The other thing is that there's a possible error. So if like the data's missing or there's something broken, we have the opportunity, if need be, to return an error as well. Okay, so how do we do this? We need to probably, I think we have enough information. Oh, there's examples. There's examples for this. I forgot about this. Okay, so in the examples, we want to learn how to do probably marshal indent. So they have a map, which they're using instead of a struct. They're getting back the JSON and a possible error. So you can ignore these lines. So this would be titles. This is calling marshal indent, and then when it's done, they have a string. So let's run this. Whoa, that looks weird. Oh, because they're using... Oh, they changed their... Oh, I haven't seen this example before. So there's no... Okay, so there's no... Sorry, this is just like fancy stuff. So there's no prefix, but there's an indent, and that will make it pretty. So it's like a pretty marshaller. Okay, so that's it, right? Oh, maybe we don't even have to define a custom marshaller. We can just, oh shoot, I forgot about this. I forgot like how efficient Go is for writing program. I don't think we need to define a custom marshaller because we've given it this meta tag. I think we have given Go enough information. So all we should need to do is, we've instantiated our titles, the year, the title, and the rating. We've saved it to a variable called titles, and then I want to get the JSON. So I basically want to JSONify it. The input would be titles. Is that a legal thing I can do? Marshal indent takes an interface. Okay, so that, yeah. Log an error, and then print string JSON, because JSON is an array of bytes, and so I can convert it into a string using this syntax. So let's see if this works, because if it does, we're done with the Go code. We put the data in like this, we need to marshal it, and then we need to send it when somebody like hits our server. So let's run this. Oh, with dependencies. Okay. And I want to delete this code. And I'll delete that code. Holy cow. Oh my god. Did you guys see that? I didn't need to define a marshaller because that... Do I even need this? Hang on. I suspect I don't. I do, because I wanted this to be lowercase and because this is cap... Okay. If you're ever doing this kind of thing in Go, this stuff has to be capital case. And if you don't want the output to be capital, then you would use reflection. Or sorry, you would use struct tags. Go will sort of freak out if you use lowercase here, because in Go, lowercase means this is a hidden variable. It's limited to some package. Capital case means it's a global variable, kind of, but it's not like, use capitals if other code will use this function. Or, sorry, I'm like getting confused. Basically, this needs to be capital, but if we don't want the output to be capital, we can override it with this sort of thing here. I bet you I could do XML now, swap that, swap this, because it's like an interchangeable data type, and then I just need to say XML. I don't know if this will work, and I've never tried this, but I suspect that's all we need to do. Oh my god. This is why Go is a big deal. Because, like, that's really cool. Once we have the data in memory, printing it is literally a matter of which package we're using. So, like, I don't think Google Go has like a YAML package. I don't think it does. I will try this, but I doubt this will work. I don't know if this is going to work. Yeah, there's no YAML. Okay, so this shouldn't compile. But if I'm using a third-party package, then I can interchange like the data to be any sort of output that I want to. And this is a really big deal. Because it means that you can write your program as sort of agnostic as possible to whatever's consuming it. So that's a big win. So now we've got this data, and there's only a couple things we need to do. For now, I'm going to put this stuff in here like that, because I don't want to have to like read from a file, because that's sort of extra work. And then all we need to do is write the JSON to the writer. So I am winging this, and I am doing fine. I have not done Go stuff like this for quite a while. Okay, so instead of putting everything in one file, I'm just going to put them in separate files and compile them together, which means this file will be just concerned with the API stuff. And that means, let's do this stuff as a global variable, just for the sake of ease. So we'll do like var titles, and then we'll put this logic inside of our API. So our API will do the lifting between taking our global variable and turning it into JSON. So this is going to be the global variable. It's going to check for a possible error, and then it's going to print the JSON, which is already in the right data type because JSON is an array of bytes, and this is expecting an array of bytes. Okay, so our API is done. Now all we need to do is, oh great, Anna. Now all we need to do, we have the type defined. We don't even need this anymore because that was just for us. This is sort of like syntax sugar. It'd be fine if we just did this. So this is sort of as minimalistic as it gets. And then now we just need to put all the raw data in here, which I can do pretty quickly because we're using Sublime. So like now, all I need to do is this. I could get rid of the first line. I could get rid of the last line. This JSON is almost equivalent to a struct literal, except that now I just need to uppercase year, title, and rating. Now, because the title of the movie might have year, rating, or title in the title, it'd be a little bit safer to do this using sort of like text processing techniques. So I'm going to use a regular expression to grab the beginning of every line. I'm going to go to where year opens and change that. I'm going to go to the very end, jump back that many characters, and then I'm going to go back here and make that title. So like now, this is fancy, and we should be able to drop that in right here. If we have any formatting, oh really? So if we have anything, so like now we should be able to use Go imports to format this and make it pretty, and that's it. Okay, so Anna said, so the thing is, like, I'm not trying to offend anyone. I think when people think about the backend, they're like PHP. And the danger with that is that if the language that you have to use to get a job done is not user-friendly or doesn't have a good developer interface, while it might be conceptually easier, because we're writing this in Go, we can do like hard things easily. Like if I wanted to do some like concurrent thing in the background and like that stuff's easy because Go is easy enough. We just need to learn a couple of things, and think about this. Our API for our movie app is like a few lines of code, and then we just like define the nature of the data. And this is the whole thing. This is amazing, right? I mean, this is really cool. So let's compile both of these together, hit our API, and then we'll see what we get back, right? Now you can imagine we could be like even more advanced here. We could be like, yo, give me just like the movies that have this title or blah, blah, blah. Like you can make the API more flexible than this by like decomposing the API, doing a custom API request and not just giving everything back. But the point is, once like that comes after you understand this stuff. Okay, so let's compile that. So we're in this file, and all I need to do is compile these two files together. So I can do go run API and struct. And that'll basically concatenate them into the same file because they're both package main. So we don't have any, like we haven't created any dependencies other than the standard library. And even with the standard library, we're just using these three. And we don't technically need this one. We just need these two. Okay, so let's compile. Oops, let's go, go run API struct. And then it's saying, hey, you have a, we're forgetting JSON in here. And then it's saying titles, because we deleted titles. No, we didn't. That's it. So now, let's do a curl request to our server, like that. And I think this is giving us, shoot, I think this is giving us the bytes, which might be fine. Wait a minute. Oh, I think that works. Yeah, I think I was missing that. So recompile, run that, and then hit the server. Cool. So I'm going to put this on, so I want to put this online. Yeah, I should be able to do this. If I deploy this to the server and I give you guys the URL, you should be able to hit the server right now and get the same response in the command line. So all I need to do is cross-compile this and send this to, I'll send this to the TwitterBot server. So I'll do like go build output API. Will this work? Yeah, it should be fine. Okay, so we're going to do cross-compilation, do go distro. So this is like, now it's ready for Linux. And then I can do go build output equal, oops, go build, output equals API, input is equal to API, and struct. Okay, so we built it as a executable. Then I just need to send this to the server. So I can do API root at go server. No, I need to be careful. Go droplet one. Like that. No. Like that. Okay, so we've sent the API executable to our server with the data inside of it. So now I'm going to open up the server and give you guys the IP address, and you should be able to access this over the internet. So like, let me boot up the server, so /API, run that in the background. Okay, so that's running. So now if I go back to my computer, can I curl that? So here's the address, and we need to do, okay, we need to use the port /API. Uh-oh. I need HTTP. Emin, do you see what I'm doing wrong? It should be pretty simple. Oh. It's like, yeah, I'm doing something wrong. But it's something like this, where I just like, let's try this, like go, let's try like go droplet. Oh, I've got the wrong IP address. That makes sense. 880 API. Yeah, there we go. So let me put this in the YouTube, and then you guys can actually access this right now until I turn it off. So I can go to channel, live. Okay, so whether you go to curl or you go to the command line, sorry, whether you go to the website or you go to the command line, you can now access this, and that will hit our API, which will give you the thing that we're working on. Okay, so now we're just hitting the API. If we hit it too many times, we might like crash the server. Just keep that in mind. Emin, does that look right? I think we did it right. Does JSON, like, I feel like there's one thing. Yeah, but like we made an API. That was it. Yeah, okay, we did it right. Okay, so now we just need to consume the API, and that's pretty much it. Right. So to consume the API, how are we doing for time? We started at like 8:20 and it's 9. Okay, so we're almost at an hour and a half. So let's just I just want to explain this. So now we would use like Ajax or Axios. Axios is sort of like the faster, newer version of like Ajax as far as I'm aware. We would use some JavaScript library that we can load via a script tag like this, right? We just use a script tag. This one looks like it would give us the most up-to-date version of Axios because we're using unpackage. And then let's figure out how to do an API. So we're doing a GET request. We're not doing a POST request. A POST request is where we send a query, but we're going to get all the data. So we're just going to do a GET request. So we need to, I think we want this one. We're going to do an Axios that takes options. The options get with the URL. I wonder if that's fine. And then it's doing a promise, I think. So it's saying then call this function with the response or something like that. I haven't used Axios before, so I don't really know how to do this. So Axios is assuming we're on our own computer, which I don't want to make that assumption. Axios remote. Let's just do GET request. Oh, of course there's a Flavio Copes article. npm. Okay. Okay, this looks like all I want to do. Okay, so let's do two things. Oops. So first, we need to get that unpackaged URL, and we're going to make a website. We're not going to use the web app because we're going to use the scientific method, and then we can check the viability of this. So let's go back to here. Okay, because it's only running on the server, and the URL is in the live. Okay, so let's make a website. So let's do like sublime web.html. So here, we're just going to make the most basic website that has a script tag that we can test whether I don't think it matters for our purpose. Okay, so then, okay, so now we're good. I'll paste this into the chat. Then this is live, Chan live. Okay, let's go there. So that's, oh no, it's not gonna let me paste a literal. Here, you guys can do the script thing. Okay, cool. Okay, so now we can go back to this blog that taught us how to do this thing, and we just need to open up our website. So let's go to here. No, we want to go to here in iTerm. We want to go open web. So now this is an empty website, but in the console, in theory, we've loaded up Axios, which is the significance of doing the test like this. So do we have Axios? Shoot, we don't. Why not? Oh, did I save it? Okay, now I didn't save the document. Okay, so here is the example. So we're going to do a GET request on our server using Axios and double check. I will use Vue, but I want to make sure I even understand Axios because I've never used Axios before. So here's our URL. We go back to Axios. I'm going to do a GET request on our custom API. Let's put this into Sublime for a second. And then let's think about this. JavaScript. So basically we're using dot syntax. So it's like there's a then, and then it's calling a function. Okay, that's a little bit more readable. And then this could be R for response. And then it's going to log the data, and it's going to log, okay, I don't care about the status if it worked. Just care about the data. So we still need to convert this into, we need to convert it into an object, which I don't know if it is already or not. Okay, this should be good. So we go into here, delete that, paste this. Oh no, what's going on? So we got a rejected promise because no, I've seen this before, but I don't know what it means. I think we need to change something about our website to get this to do this thing. So let's do this. Script. Let's put this in here. Let's do use strict. Let's put this here. Oops. Oh, no. Okay, let's put that, oops, let's put that there. And, okay. So now let's find out why. So we're accessing the API via a GET request. And then, so we don't have any error handling right now. Okay, so this should still fail. Okay, let's find out how to deal with this. If I understood you, you're doing an XML request to a different domain. So your page is being blocked. So if we have, okay, so if we're doing this from the same server, it wouldn't be a problem. But because we're going from point A to point B to back to point A, the browser's basically complaining. Wait a minute. Is this so complicated? Oh. No. Come on, that wouldn't work. We're not doing that. Let's try like this, Axios, and then let's put the same message. Okay, so this is an error on the Axios documentation. Blah, 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 blah. Looks like your server does not include in the response to the options. Will fail. Oh my god, come on. Oh, where do I do that, Emin? I haven't done that before. And do I do that to our website, or do I do that to the server? Oh, if I do it to the server, then I would need to go to here, and I need to do something to the request, because we're not doing anything with it. Yeah. So we go to the server, and when we handle, we need to recompile this. We need to set the header then. So, and I want to just show you this. When you go to a website, what happens is you get headers back from the website, and you can see them somewhere. Emin, let me know if you know where. Where is it? Somewhere. It's basically like the website's giving you some information, but that information can also make or break things, which I don't know where it is. But basically, it's called header. We have this data, but there's also this non-visual data that it's also sending. And in this case, our server is too stupid to deal with that. So let's go to Golang request set. No. Okay, let's set this header. Okay, so this should be pretty easy. Yeah. So in theory, that's all we. Does that look right to you, Emin? That's all we need to do? Because I thought we would need to talk to the request, not the response. But if it's fine. I just didn't know that. So we're basically giving it some like extra authorization to do stuff. Which case, that's all we need to do. Yeah, that would go there. Okay, let's do that. So we're going to recompile. We're going to go to cd source. Go space cd source, and then we need to do go build output equals API struct. Okay, cool. Now we need to go back to the server, kill the first one. So this is cool. Nick, if you're around, you should see this because this is pretty cool. We have a program running in memory, which I can see here, and I want to kill API. So here is it's called the process ID. It's like the identifier for the computer so that I can just kill it. So I'm going to kill this process. So now our server's offline. And I'm going to send the new one. Right, so we're going to send the new API, which has been I don't think I cross-compiled it. Go distro. Okay, so now it's cross-compiled. Now I do scp API root at go droplet, like that. Okay, so now it's being sent to the server. Server received it. We're going to fire up the API again in the background. Oh shit, did I do that wrong? Yeah, I thought it was the request, not the okay, sorry. Yeah, I had a feeling that was wrong. So remove API. Remove API. Recompile. And then Emmett, it's saying I can't call header. Wait, is there something wrong? Oh, is this not a function anymore? Let's try that. Okay, that worked. I'm going to assume that's all we need to do. Okay, so send it to the server. Okay, Now we're going to fire it up in the background. Let me make sure it's not already running. Okay, it's not running. We do /API and oh shit, let me do it in the background. Okay, so now we're back. So let's just refresh our blank page and see whether or not Axios now works across different websites, which was the whole point of that, which I can't find it anymore. Where did it go? Let's go to here and do open web. Okay, let's see if we got the data. Oh no. Emin, do you know what's going on? So we can still hit the server, but it doesn't like our header. Oh, it's so annoying. Let's try this one more time before we give up on it. Golang. Let's try this again. Okay. Sorry, I'm gonna try this on the request. Sorry, on the. I'm just gonna copy paste that and try that because I'm a little desperate. Okay, so. Thank you, Anna. It's okay, I mean, don't feel bad. Anyway, let's try this. So this first line is probably not needed, but we'll keep it because Stack Overflow is our friend right now. Okay, so let's recompile this one. Okay, so let's kill, so ps AWX, AUX, kill 23112. Okay, we kill our command, and then we go to SCP. Okay, it's sending it to the server. /API background. Okay, run that. Go back to the website here, and then now we check it. Okay, so we did it. We've connected our backend to a front end, not the right front end, but a front end. And by the looks of this, this is already parsed. So these are like native data types, which is ideal. Okay, that was really cool. Okay, so now we can go to our website. Where did it go? Here. So let's save. Let's do like this. var response is equal to an empty thing, and then the response is data. We're going to set response to the, let's do like global data like this. By the way, if you wanted to put this in like a func main, just like in a Golang program, you can actually use an anonymous function. So you can do like function, put this in here, 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 and like you call it immediately. It's something like this. If you wanted to have sort of more organized JavaScript, that would be totally fine too. Okay, so let's see if we can get data attached to this global variable, and if we can, I think we're good to go back to our website. Okay, so now we just go back to web and run that, and we're going to ask whether data has data, and it does. So let's say data length should be 250. Let's say data at the 0th index. Yeah, and these are native data types. So I think what we should do is take a break, come back in like 20 minutes. We'll just try to connect this to our actual web app, and then we will be very confident about building something from scratch that is useful. Any questions, comments, or thoughts before we take 20-ish? That's okay, Emin. This is all going to be... So when we do YouTube for the live stream, it caches it, and then once it's finished processing, which takes like an hour per video, it's on YouTube. So you can catch this after the fact, and all the comments will still be a part of the video. So if I like paste a link, you can have access to the link just like you were here the whole time. So no problem at all, don't feel bad. Anyway, Anna and Nick, if you're there, let me take 20, we'll come back at like 30-ish, 30 past. Then we'll try to finish this, and then we'll try to figure out, I have some ideas about how do we do the, how we do like the little game that we sort of have the idea for. Anyway, let's connect soon. All right, I'm gonna turn off the stream. Thanks, guys.